Hey everybody, how's it going? Oh, here we are, another PKQ&A. Good to see you. Good to have you. I've already got the Discord open, and looks like we've got a questions queue building up. Possibly, I don't know. No one's in it currently, so maybe not. But that's okay. Welcome to the Q&A session for tonight. I know it was kind of short notice there. It was one of those things where I was like, oh my gosh, we need to do one this week. And tonight was really the only night that made sense. Tomorrow is booked. Friday's booked. Saturday morning gets a little weird. And it just seemed like tonight was going to be the best night, especially because we've already talked about for loops. And we talked about the random object. And then we did a little bit of review before that on while loops. You know, we got while, do while, and things of that nature. So, oh, sweet. Lots of buffering tonight, too. Awesome. All right. Well, hopefully the lag is not too bad. Might have to ask my wife to stop playing Assassin's Creed. It's her thing. If we're not hanging out together, she's playing Assassin's Creed. So, there's that. All right. So while we're waiting for questions to build up in the queue, and right now it looks like there really isn't much in the way of any questions, let's go ahead and talk about some things that might be useful to you. For example, I'm gonna hop on over here. Let me. I know I'm still on Facecam, and that's okay. I intend that for right now. I'm gonna switch my workspace first before I show anything off. And I suppose the next question I would have for you is, okay, so how are the assignments coming? You've got birthday calculator and you've got number guessing game, right? And these are two fundamentally simple applications that you're expected to build. One of them is a lab, one of them is a project, and the project one, to be honest with you, is actually a little simpler than the lab in my opinion. I was just looking over the requirements, but that's okay. That's kind of the intent, right? Yeah, the lab might be harder, but the project, the whole purpose of the projects, and the reason I give them to you in the sequence that I do, is that I am testing your competency based on that point in time in terms of our course objectives. What have we covered? What do you know? With what are you struggling? That sort of thing. So, yeah, the project is simple. The number guessing game is simple. But that's okay. It's testing virtually everything that you've learned up to this point. I don't know if you've noticed that, maybe you have, but it's testing virtually everything that you've learned up to this point. So that works out great in terms of intent, right? Okay, I'm just cleaning up my code here, and let's go ahead and bring that into view. Yeah, and I'm noticing that the Twitch stream is actually kind of laggy. You know, I should have been smart and reset my router before we tried this. So, makes me wonder. I'm going to see really quick if my wife can just turn off her network connectivity. Maybe that'll help out. So, just 1 second. And while I'm doing that, let's give you something to kind of chew on for a second. I made a video about this, and I haven't posted it yet. I'm hoping to get it posted tonight. But I want to give you some practice here, okay? Let's pretend for a moment. I'm a huge RPG nut. Don't know if you caught that last stream, but I'm a huge RPG nut. And sorry, I'm just checking which part of the server I should be on. Okay, there we go. I'm a huge tabletop RPG nut. Love them, love them, love them. Always have since I was a kid. And one of the things that's common in a tabletop RPG like Pathfinder or D&D or any of those games is that you have a character sheet, and that character sheet has stats on it, right? It has like IQ and charisma and physical beauty and strength and things of that nature. Normally what happens is that you have to roll those stats using some combination of dice. You're either going to have like 3d6, for example, which means 3 6-sided dice. And that will go for each of the stats. You would have to roll those dice for each of those stats, right? Not just one time and then apply it to all of them. You'd have to roll 3d6 for each one of those values. So the question I'm going to pose to you for just a little bit of practice really quick here is, what if I want to roll 8 attributes for a character? Here's what I'd like you to do. Create a method that takes in... We're going to have like a dice roller method, right? Because we might roll different dice in different situations. So create a method that takes in the number of dice and the number of sides and returns the value rolled by those dice. So this is a dice roller method, and it's going to take in how many dice we're rolling and how many sides, and then it's going to return that value. Do that much to start. And while you're doing that, I am going to be texting the wife to say, please turn off your network connection. So try that out really quick. I wish I had some like legal to use background music so that you knew that this thing wasn't just stalling out. But go ahead and do that. I'll give you just like 30 seconds more, and then I'll talk to you a little bit more about it. Well, okay, 60 seconds more. All right, let's see what's going on over here. So I'm leaving this up on purpose, but I'm going to come back here to Facecam for just a second so you can see what's going on. I'm trying really hard. Let's see. Let's go to General Help. Students. Interesting. I see a lot of students playing games. That's good. That's good. You guys need some downtime, so that's good. Let's also check to see what's going on in the general conversation here. Awesome, awesome. All right, so let's continue on with our code demo for right now, and then we'll come back when we have some questions on the Discord server. So I want to create a method that takes in a number of dice and the number of sides and returns the value rolled by those dice. Also, you might notice here that I've got a program class, and I've got the main here, and I've got buffered reader and random. And this is set up because this is like my demo environment for when I'm doing YouTube videos. And naturally, we know better now, don't we? We know better. So, you know what? Let's fix this. Let's go into, in fact, you know what? I built this demo for a specific thing. Let's go ahead and build a new project really fast here. Let's go to Other and Maven like we always do. And then I'm going to go ahead and make a simple project. And there we go. And then we will do our typical generic group ID. You know, I think I'd like to read the documentation on what a group ID actually does. Professor Cox explained it to me briefly, but I'd like to have a deeper understanding of this because I'm starting to wonder if maybe there's a better name I could come up with for this, but this is okay for right now. And then here we will do, let's see, let's just call this the Twitch QA. Yeah, Twitch QA Proj. There we go. Twitch QA demo. Let's do that. And hit finish. And now I've got this other project here. So I'm going to go ahead and close this thing off. Don't need that right now. And in my Twitch QA, I'm going to do what I always do. I'm going to go ahead and add a new package to that first folder. Here's package, and I'm just going to call this app, inside of which I'm going to add our driver class like we learned earlier this week. So here's class, here's driver, here's main, good to go, right? And I'm going to go ahead and make a demo class in another package. So I'm just going to call this demo.run, and it doesn't have any reference yet, but you've seen me do this before, and I'm just going to go ahead and call this, I think I'm going to make it the demos, plural, demos package, inside of which I have the demo class. Now, this doesn't exist yet, but it will. When it does, the compiler will be satisfied. So let's go ahead and add a new package, and we'll call it demos. And then inside of that package, let's add a new class. Oh, no, not an interface. Let's add a new class. Let's add a new class. There we go. And this is going to be called demo. Remember, we're not doing a main here because this is a functional class. This is not the main class, as it were. This is not the driver. And then here I will have public static void run parens and curlies, and we are golden. Once I save everything, you'll notice that all the errors in this project go away. This is one of those times, and you'll see this a lot in your coding life, this is one of those times where you need to be smarter than the IDE. The IDE and the compiler only know what's happened up to this point. They don't know what you're planning. They don't know what you intend. You have to figure all that out for yourself. And so when the compiler gets mad at you, even though you know you're about to fix everything, you don't have to freak out about that error right now. You know what you're doing. You're going to fix it. So if you're smarter than the IDE, you can say, that's okay that you're in an error state right now. I'm going to fix it in a moment. I'll come back to you later. That's okay. Don't freak out about those red squiggle worms. They're there to help you, not to hurt you. All right, so here is my run method. And I'm going to make, per the instructions we had a moment ago, right? I'm going to make a public static void, not void. Let's do an int, and let's call this roll dice method. That's all it needs to be, roll dice. And it takes in the num, let's see, int dice and int sides, right? So this first number represents how many dice we wish to roll, and this next number represents how many sides. And you know, if we're being especially creative here, then we might add a couple of other parameters. But you know what, now that I think about it, I think I'm going to hold off on that for just a moment. The idea here is we want to roll the dice specified and then return the result. Now I put that in quotes because the way we're going to write this method, we're not going to have any dice models. We're just going to do some math and maybe use the random number generator. Of course, use the random number generator, and then go from there. Now, for the purposes of our demo class, I am going to add a public static buffered reader. To be honest, I don't even know if we're going to use this yet, but it's nice to have around. And let's just call this Buffy, like we do. And no, I'll give it a better name, input reader, like we should. Better names are better. Here we go. Buffered reader, and then inside there we have new input stream reader. Oh my gosh, my capitals are out of control today. And then system.in, of course, like we've always done. Semicolon to wrap it up. That moment where I'm trying to decide, you know, for those of you who attend the stream and those of you who watch the stream in the archive, it makes sense to me that if you're going to be a part of this, maybe you should get some rewards. Like maybe you should find out information in advance. Maybe tonight, instead of passing the buck with throws IO exception, maybe we just handle the exception ourselves. All right. So yeah, I'll come back to that later. But for right now, back to the code. Let's go ahead and Control-Shift-O, and let's get our imports going. Here's buffered reader. Here's input stream reader. Great, our reader works. Next, we want to have a public static random RNG. That's random number generator for short. And then we want to have a new random object. And let's go ahead and do a Control-Shift-O. Now, I will point out something briefly. First, just to make the compiler happy, I'm going to make an int result, which I start off at 0, and then I return that result by the end of the method, right? And right here in the middle, this is where we're going to do stuff. This is where we're going to do all the important things. I'll get rid of that comment in a second. But what I wanted to point out was, you know, I had some questions today about the random object versus, so let's see, we can generate a random number using the random, let's do random object. That's what our RNG is, right? What RNG is. And then we can also generate a random number using the math.random method. And this is kind of an interesting concept. I could go either way, and the question becomes, is one way preferable to the other, or are there certain cases where I'd use one and not the other, and so on. In truth, the random object came much later than math.random, and the random object kind of encapsulates all of the random functionality that you'd ever need. And so while you could use math.random, there's really not a great argument for why you would over random as an object. The only argument you could have, and by the way, just so you know what this looks like, I could have int num1 equals, and then we do RNG next int, but you'll see that like next has next int, next boolean, next double, next long, next float, next Gaussian value, if you understand Gaussian math, and then next bytes. This is actually like a collection of bytes, which is very interesting. And so you've got all these different next you can do, and typically we do one of the two next int methods. So I'll just do next int here, and let's say for a moment, let's declare, just briefly, just temporarily, let's declare a max and upper bound. Let's just set it equal to 10. And so here I might do a max, and remember that if I do that, then it's going to, it returns, excuse me, it returns 0 through max minus 1, right? So right now, max is 10, therefore this would return 0 through 9. Generate a random number using the math class. If I do int num2 equals math.random, well, what's interesting about this method is that it returns a double, not an int. That's the first thing to notice. The next thing to notice is what it actually will return value-wise. It says here that it returns a double value with a positive sign, so it's a non-negative double, and that non-negative double is going to be greater than or equal to 0, so it could be 0 or higher, and it will approach but never actually reach. It's going to be less than the number 1. In other words, 1.0 is exclusive as an upper bound goes. And so here it says return values are chosen pseudo-randomly with a approximately uniform distribution from within that range, blah, blah, blah. So that means that when I call this thing, when I call random, it actually returns a double that is less than 1 but greater than 0, or greater than or equal to 0. In order for me to make this an int, right, I'm going to have to multiply it by my max. Now, when I multiply it by my max, because this is a double, this is going to start doing floating point math. So I'll have 10 times, well, let's say this is just 0.5 to keep it simple. If this number is 0.5 and I multiply it by 10, I'm going to get the number 5. But even if it is the number 999, or no, 0.99999, I'm only going to get 9.99999 when I multiply it by 10. In other words, once I'm done with this, first, I still have to cast it to an int. And then second, even when I'm done with this, what you see right here returns 0 through max minus 1. It actually does not change the outcome whatsoever. But notice that here, using the random object, I just have to give it an upper bound, and I get an int, and voila, we're done. Down here, I have to get a double. I have to multiply it by my max or some arbitrary number. I have to keep in mind that that is floating point math right here. So that means I have to cast it before I can store it as an int. And even then, the returns are exactly the same. So is there a point to using math.random? Well, this actually could be useful in certain mathematical situations. However, for the most part, the random object is designed to handle all of your random needs. This existed first, and they can't get rid of it for reverse compatibility reasons. But the random object came out later and ended up having all the features you could ever want. So that's why we have random objects versus math.random, and that's the difference between these two things. All right, let me go ahead and clean this up again. So I want to roll the dice specified, so the number of dice and the number of sides, and I want to return the result. So knowing what we know now, there are actually two approaches I could take here. We could say two approaches, right? And the first approach that comes to mind is we could use the for loop approach, because that is probably what most accurately reflects the real world. In this particular case, I'm going to roll the dice, but I don't need to preserve which die rolled which number. I don't need to worry about that. But to simulate rolling individual dice, I could say, okay, 4, and then here let's do int, and I'm going to use the starting condition that you would most often see in the wild, and I'm going to say int I equals 0, and as long as I is less than the number of dice, then go ahead and increment I at the end of the loop and do the thing, right? So why this structure? This is actually the most common version of the for loop you will find in the wild. Coders like to just say int I. Remember that I is short for iterator count or iteration count or index, or sometimes it's just short for int. Like this int doesn't represent anything particular other than the starting point of the loop. And so you have int I equals 0. And as long as I is less than the number of dice, so if they say let's roll 3 dice, this is going to be 0, 1, 2. That's 3 times through the loop. So if they say they want 3 dice, we'll still loop 3 times, not a problem. This is the most common thing you see. Start at 0 and run as long as you're less than the max. This avoids us having to do a double check, if you will, where we have 1 as our starting condition and less than or equal to. This is not a big deal. This is not a huge sin. This is very readable. But most frequently, you will find this in the wild. So just get used to zero-based counting and what that means. And to help you with that, I'm going to write my for loop using zero-based counting. And now inside here, what do we want to do? Well, we want to take result, and we want to add to it and record add that addition. We want to record the result of adding rng.nextInt, where the upper bound is the number of sides we're rolling. But remember that if the number of sides is 6, this is going to return what? This is going to return 0 through 5, which means, technically speaking, the lowest value I could get here is actually 0. After I roll 3 dice, if I roll perfect low numbers, I will get a 0 at the end. We don't want that, because in reality, if I'm rolling 3 6-sided dice, which is referred to as 3d6, by the way, if I roll 3d6, then the lowest I should have is 3, and the highest I should have is 18. So remember, what do we do here? I don't need 0 to 5, right? I don't need 0 to 5. I need 1 to 6. So how do I fix that? Right? How do I fix that? Remember what we did in class today? Well, if we recognize that this is a this is a range of 6 digits, and this is a range of 6 digits, both are consecutive, right? Then I can take the minimum of the higher range and I can apply it as a shift. So that if this method returns 0, I'll add 1 to it and it becomes 1. That ends up being the lowest number I can roll. Conversely, this is 5, the maximum number this thing can generate when sides is 6. If this returns 5, I add 1 to it, so the maximum number I can generate is 6. That's us taking this 0 to 5 range and shifting it to 1 through 6. Both inclusive, right? All right, so once I'm done with result, I'm going to go ahead and return that result. This is actually a very simple method, right? It's not that bad. This is the for loop approach. However, you might recall earlier that I mentioned we don't need to preserve the knowledge of which die rolled which value. We don't need to know. Instead, we can look at things like, okay, well, all I really care about is the total, right? So we could actually do the mathematical approach. Remember, most problems are easily solved using math, right? So what does the mathematical approach mean? Basically, we just have to understand the range of possible values. We just have to understand that, because if we know the range of possible values, we can do this in one line of code and a shift. So, for example, if they are rolling 3 dice at 6 sides each, then that means that our lowest value is the number of dice we have, and our maximum value is our dice times our sides, right? Because we're talking about dice that have a 1 at the low end and then the number of sides at the high end. Since the number at the low end is a 1, we just need to know about our dice. So 3 dice times the low end, which is 1, gives us 3. All right, fine. So let's do int. Let's follow previous examples today. Let's do int min and max. Remember how we did this earlier? We said, oh yeah, you can declare these all in one line as long as you comma separate them, and they'll get their default 0 values and all that stuff. Okay, so the mathematical approach says take result and set it equal to rng dot and oh, you know what? I'm sorry. Before I do that, we actually know in advance what this is going to be, right? And I'm setting these up as min and max so that they're readable. Technically, I don't have to store these values, but I want to make sure these are readable and you understand what's going on. All right, so let's do dice times sides. There we go. So my minimum is going to be equal to my number of dice, and my maximum is going to be equal to dice times sides. So here in RNG, we can call next int. And then we can apply that range formula that we talked about earlier today. In the case of 3 to 18, I know that there are 16 numbers there that we need to represent. So I need my upper bound here to be 16. Now, how did I get that number? Well, I took the max, which in the case of 3d6 is 18. I subtracted from it the min, so that in this case that would be 3. So 18 minus 3 is 15. That would give me 15 numbers, 0 through 14. But remember that we always add 1 again because the lower bound counts as a valid number. So here I would have 18 minus 3, that's 15, plus 1 gives me 16. So I now have 16 numbers. This will return 0 through 15. And then finally, if I add my minimum as a shift, it pulls that 0 over, it pulls the maximum over, and in my example, that would result, if this returns 0, and then I add min, that's going to make it 3. That's my lowest value possible. If this returns 15, I'm going to add my min to it, and that's going to make it 18, my highest value possible. So if we take the mathematical approach, we'll be right every single time. So long as they give us valid values for dice and sides, we're fine. All right, cool. So we've got two different approaches here. We can either use a for loop or we can use the mathematical approach. Since we're in a situation where we don't have to know which die rolled what, we can get away with the mathematical approach. In other words, and you don't worry about deleting your notes, but in other words, this is all the method I really need, right? This is all I got to do. And technically, since min is just equal to dice, I could just put dice here instead of min and cut down on my variables. Technically, I could do all the math in here. It's just that it becomes way less readable. So I like having variables that make things a bit more readable. All right, so this is us rolling dice, but we haven't actually tested it yet, and you're not done till you test. So, really quick, let's just go ahead and sys out, and let's call roll dice. And let's use the example we've been using. Let's do 3 dice at 6 sides each. That means that we should get numbers between 3 and 18 inclusive. Let's go ahead, come back over here to the driver because I haven't run this yet, and hit play. And there's the number 11. And if I hit play again, there's the number 9. And then here's number 15. That's cool and all, but what can we do to make this a better test? How could we see more numbers, right? Well, I'm only trying to get between 3 and 18 at this point. That's a total of 16 numbers. What if instead, let's do, oh, that's fun. Let's do a do. Why not? Let's do a do. And here's my while, which I'll fill in just a second. And I'm going to go ahead and I'm going to say string input equals the empty string. And inside, after we do the dice roll, let's go ahead and say that input equals Buffy dot read line. And now here's the corker. I'm sorry, I said Buffy. That was a habit. I meant to say input reader. Input reader dot read line. Okay. And now that I've done that, down here in my while, I'm going to say, hey, as long as input does not equal null and input dot is empty. In other words, as long as I don't enter anything, or as long as input is null. I'm sorry, I said not null. Let's do equals equals null. As long, if no, there we go, I fixed it. If input is null, or if input is empty, repeat the loop. That's what I'm saying. Now, hang tight. We've got our common error here. Yeah, I see some of the chat going on in Twitch. That's very interesting, and I appreciate that. However, I guess I'm really curious if there are any live questions that need answering. Oh, there we go. There's Sophie. Hang on one second. I'll pull you in just a second. All right, so hang tight. Here we go. Notice that this input reader line is red, and we've seen this 100 times. And normally we get rid of this by just adding throws IO exception. But tonight, and tonight only, until I show it in class, I'm going to show you how to handle this situation. Instead, we want to do what's called a try and a catch. What we're saying here is I'm going to try doing this code that I know may throw an exception. And if it does throw an exception of type IO exception, I'm just going to call it IOE for short. If it throws an IO exception, got to do my import. Then here I'm going to say sysout is going to be something broke. And then I'm going to throw new, let's see, throw, can I do IOE? Can I do that? Will that let me do that? It won't. I think I just do throw. No, it won't let me do that either. Let's do throw new IO exception. Let's see. There we go. No, just this one. Huh. It's being a bugaboo. Let's see what it says here. Let's see. Insert to complete the expression. See, then it gets mad again. Oh, and then of course I'd have to say that this throws an IO. That doesn't actually fix anything. Let's do this. Let's just keep it that way. And then instead of this long check right here, I'm going to add a Boolean called keep going, which is going to default to true. And here is my input read line, and then keep going equals this check, at the end of which I'll put a semicolon. And then here I'll just put keep going. And the reason I'm doing that is because inside this catch, if this exception gets thrown, instead of allowing it to break my code, I'm going to go ahead and catch the exception, stop it, and then I'm going to say system.println, and then something broke, and then here I'm going to just say keep going equals false. In other words, I'm going to stop this loop and have it return to whoever called it. Okay, so now I've got a do while loop that has a try catch inside of it, and really all I'm doing is just printing out this number. Now the reason I set up this slightly verbose method is because when I hit play, now as I'm testing this, if I just hit enter and don't enter anything else, right, I get numbers. I get as many as I want. In fact, I can do a Control-Z to submit null, and then it just goes on infinitum. That's an issue with buffered reader, but we'll talk about that later. Yeah, this thing is just null infinitely. But you can see all the numbers that it's producing. And if you watch carefully, you'll see a 3. And if you watch carefully, you'll see an 18. And you won't see anything higher than an 18. You won't see anything lower than a 3. So we've accomplished what we came to do. I'm going to go ahead and clear that out. Alrighty. Okay. We can talk about this a little bit more later. But for right now, I want to talk to our good friend Sophie. So I'm going to grab Sophie here and bring her into the chat. Sophie, how you doing? Now remember, Sophie, you got to hit push to talk so I can hear you. Oh, I don't know if Sophie has her push to talk turned on. And I'm not sure that she can hear me just yet. That's okay. Sophie will get that fixed, then we'll talk to her.
Hello.
Oh, there you are. How you doing? Push to talk
Yeah.
so I can hear you.
Can you hear?
Yeah, I can hear you. Oh, also, turn the volume down.
Sophie has her push to talk turned on.
I do.
And I'm not sure that she can hear me just yet.
Okay, so go ahead and turn down the stream because we can hear everything that's going on in the stream, but it's delayed. So if you can just mute the stream, you'll be fine. All right, Sophie. So earlier you said that you were stuck on week 2 exercises. And when you put a sys out, it won't run or tell the user to input a number, and you don't know why. Is that correct? Oh, Sophie, you got to hit push to talk. Ah, I see. So what she's saying right now, you can't see this. Hang on a second. Let me take this off of the code cam. There we go. So Soph is trying to talk to me, but she's saying that Discord won't let her hear my voice through this chat. So she's trying to fix that really quick. Because I promise, my audio is registering. And I'm going to just double check, make sure that you're not deafened or anything. Nope, not at all. Just making sure. All right, cool. All right, so Sophie was saying that she was having some issues, not only with like how her code's executing, but also she was saying like, how do we do problem 2? And that's a good question. For those who don't know, I'm going to go ahead and pull up the write-up. Problem 2 is kind of interesting, and it's purposely a little... It's worded interestingly. It's correct. It's not an incorrect wording, but it can prove challenging to understand the first time or 3. So, problem number 2 in the weekly exercises says... Hang on one second. Says... prompt the user for a year and analyze that year and tell the user if it was a leap year. And the leap year is so if it meets these criteria. English pro tip of the day, criteria is plural, criterion is singular. All right, so back to this problem. If the year is at least 1582, then it's partially qualified to be a leap year. So it has to at least be 1582. That means greater than or equal to. It could be 1582, but it can't be less than 1582. And then the year is evenly divisible by 4. Normally, that's a slam dunk. Normally, that's a leap year. Unless it is also true that it is divisible by 100, but not 400. Now, this is an important distinction because then I give some examples down here. Notice that the years 2000 and 2004 are both divisible by 4, right? And then, let's see. And that's interesting. Hang on a second. Oh, yeah. So 2004 is a leap year because it is divisible by 4, but it's not evenly divisible by 100. So we don't have to check this 400 thing. As long as it's divisible by 4 and it's not these things, then we're fine. And the year 2000 is divisible by 4, and it's divisible by 100, and it's divisible by 400. So that kind of puts all the nails in that coffin, right? Like it's absolutely a leap year. However, then we get to years like 2003, which is obviously not divisible by 4 at all. And if it's not divisible by 4, it's not going to be divisible by 100, and it's not going to be divisible by 400. But on top of that, there's the year 1900, which gets really interesting because technically 1900 is divisible by 4. But, I'm sorry, it's divisible by 4 and it's divisible by 100. But it's not divisible by 400. So, yes, it's divisible by 4. Yes, it's divisible by 100, but not 400. Therefore, it's not a leap year. All right, so those are the explanations. Those are the examples. Yeah, so Sophie's trying to... She's having some technical difficulties, so she's trying to fix that by like jumping on to the phone. So I'm gonna go ahead and grab Sophie and drag her into this room. Hey, Sophie, can you hear me now? Now on your phone, you may still have to do a push to talk command. I'm not certain.
Yeah, I can hear you.
Awesome, good to have you. Okay.
Yeah.
All right, so I just finished explaining to the audience what problem 2 means and what logic we're looking for, but I haven't talked about code or anything else. So tell me what question you have right now.
Okay, so for problem 2, I was having a problem with setting the boundary, so y can't be any less than 1592 or whatever
1582?
the number is.
Mm-hmm.
Yeah, since you set a boundary, and I was wondering, how do I make it divisible by 4? after I've done that. I was
Okay.
going to do modulus, but it needs to be a Boolean.
Yes, that's true. And mod is exactly the kind of math you want to do. But remember that mod returns an int. And so then we have to take that int and we have to analyze it to see if it meets some criterion. That's what's going to generate the true or the false. So you're on the right path. You're just missing a tiny step in the middle. That's all. Actually, it's a tiny step at the very end. So let's talk about a similar but different example. Imagine for a moment, let's see, and I'm purposely, I'm writing code in the stream as we're doing this. So I'm going to make a demo method here, public static void, and I'm going to call this Sophie's answer, right? We'll call it Sophie's demo. Let's do that instead. Sophie's demo. And just to make sure I don't screw this up later, I'm going to change my run method so that it calls your method. So let's call Sophie's demo. There we go. Okay, so imagine for a moment that you want someone to tell you how old they are. So you want to prompt the user for their age. Now, there are certain values that we can exclude right away, right? Like if someone's going to tell you their age, what values are not acceptable?
15, anything less than 1592.
No. Listen to the question. I'm asking the user how old they are. I'm asking for their age. So what values will I not accept? If they tell me their age, what numbers will I not accept for their age?
Oh, anything less than anything super young.
Okay, but what's super young? We have to define that, right? Like right now you just said anything super young, and that's great, but
Under 14?
well, maybe are children under 14 literate? Can they read our application?
Oh yeah, so anything under maybe 6 or 5.
Maybe 6 or 5. Yeah, let's do less than 5 just to be on the safe side, right? Anything super young, which we define as less than 5. Okay? So anything less than 5 is probably not legit. What about on the upper end? Like, how old do you think is not realistically old? Like they're not alive anymore.
0
Oh, that's
or
young.
negatives.
That's super young, right? But isn't 0 and negatives less than 5?
I'm sorry?
Aren't zeros and negatives less than 5?
Yes.
Yes. So we've already got that covered. What I'm asking is, how old is too old? Like, when do you think that they're just automatically dead?
In their hundreds.
Like, which one?
Let's say 105.
Well, you don't want to do 105. The oldest person in the world is 122. So, I'll tell you what. How about we make the cap 125? It's been a long time in the history of the world since someone was older than 125. At least as far as I know. If we do a quick Google search, I'm sure we could find the actual highest number we've recorded. But let's just say 125 is legitimate, okay? So, you already know how to prompt them for their age. You already know how to read their input. And so I'm going to do this really quick. Let's see. It says prompt the user for their age. So let's do read their input. And then we'll say parse and store to an int. You already know how to do all that, okay? So I'm just going to declare an int here. I'm going to call it age. And I'm just going to set it equal to 50 as a default value. I don't really care what the value is right now. Normally, we would write all the code so that we have a user given number, right? I'm just going to give it a hard-coded number for right now. So let's pretend that we have a value for age that comes from the user. Now, earlier you said you're not sure how to enforce that their year is not less than 1589, I think it was, right?
I mean, I have the why if y is less than 1592, then system out, say, please choose another number.
Right, because anything less than, I think it's actually 1582. Anything less than 1582 is not valid input, right? So
Right.
it sounds to me like you absolutely do know how to stop them from, or how to catch bad input if it's less than
I
1582.
do I do understand. I confused going to like if y is greater than 1592, and then I kind of got stuck.
Okay, so hang on a second. First of all, let's make sure we're saying the same thing. The number is 1582, not 92. It's 1582.
Oops, sorry.
That's okay. So you're saying that once it's greater than or equal to 1582, you get stuck? Is that what you're saying?
Kind of, yeah.
No, no, no. Don't say kind of, because I don't accept that answer. That means that I've got something right, but I've also got something wrong. So I'm sorry. Ask the question again.
Okay, so after I set the boundary, so if y is less than 1582, say, please choose another number. If y is greater than 1582,
Oh, your phone's breaking up. I'm so sorry. So after you find out that the number is greater than 1582, what do you do?
After I set the boundaries, I got confused with how to get the system to divide that and then display it.
Okay, so that's just basically, it sounds like you have the right range of stuff for the most part. I did notice something you said, and maybe your code already has this fixed, but you're looking for numbers less than 1582 as invalid and greater than 1582 as valid. What about the number 1582? That's not less than and it's not greater than. It actually is the number 1582. What does your code do in that case?
I don't actually have that part.
Yeah, we got to be careful because 1582 is valid input. So how could you change your code so that it allows 1582 as well?
Set it 4 years lower. Oops. So maybe do 1578.
No, don't do that. Don't do that because your logic says if it's greater than. So is 1579 greater? There you go. Greater than or equal to. You could do greater than or equal to, or technically, you could keep it greater than, but just say greater than 1581. But then the logic gets a little weird if the previous number was not the same thing and so on. So I would do greater than or equal to 1582. And on top of that, you just checked first to see if it was less than 1582. If we want greater than or equal to, that's the rest of the numbers, right? So if it's not less than 1582, do you still need to check that it's greater than or equal to 1582?
Yes.
No. If there are really only three possibilities, right? And those three possibilities are greater than, equal to, or less than. And in two of those cases, greater than or equal to, we accept the number. The only time it's invalid right out of the gate is if it's less than. If it's not less than, then we know for a fact it is either greater than or equal to. So we don't have to check for that. If we check for less than first, and that's false, then we know the year is at least a candidate year. It's at least past the first test. So we don't have to check for it. So you can make that an if-else as opposed to an if-else-if. Does that make sense?
Yes.
All right, cool. So now let's move on. Let's move on to this thing. The year is evenly divisible by 4 unless it is also divisible by 100 but not 400. So let's talk about that in principle. Right now, you were saying you're not sure how to divide it by 4 and then display that. What do you mean by that?
Well, with my code, I actually have an if, else, if, and then else, which is obviously wrong. And it always ends up with an error which says syntax error, enter assignment operator expression, and
Okay, so because I can't see your code, what that tells me is there's a line of code in there that the compiler thinks you're trying to use for assignment, but it's not assigning to anything. It's also possible that you're trying to make a comparison, but you don't have it set up as a comparison. So we have to figure out what that code really looks like, right? Um, let's see. Let's talk about principles at work. I'm going to change the body of Sophie's demo method here, and I'm going to change this to int num, and then I'm going to go ahead and go through the rigmarole of doing let's see, string input, and that's going to equal our input reader dot read line. And I'm going to go ahead and wrap this in the same kind of try catch I had earlier. So this is me not passing the buck. This is me actually handling the problem. Let's do this thing. And I'll fix it momentarily. And I don't think I need that line just yet. There we go. All right. So I'm going to declare int num outside of the try, and I don't need to give it a default. I'm going to assign it inside the try. And then inside the try, I'm going to say num equals integer.parseInt, and that's going to take the input. There we go. And then before I do any reading, I'm going to do the prompt. So let's do the sys out, and let's do print, and then let's say enter a number. And let's pretend for a moment that all we care about is determining whether the number was evenly divisible by 7, for example, which is that's actually one of the previous problems. Let's say 13. Let's check to see if number is divisible by 13. So, Sophie, how do I check to see if number is evenly divisible by 13? How do I figure that out?
You could do an if statement saying whatever variable you choose for the user's input module by 13, and then 2 equal marks equals 0.
That's exactly correct. What is that equation really saying? When I say num mod 13 equals 0, what is that equation really saying, Sophie?
If the number is divided by, if it's divided, is there any leftover numbers?
That's right. So if I take num and I divide it by 13, is the remainder 0? Because if the remainder is 0, that tells me that num was evenly divisible by 13. It was some multiple of 13, right?
Right.
So to me, it sounds like you know exactly how to check to see if a number is evenly divisible by 4. Isn't that the same principle?
It is. I think mostly mine's just probably a formatting error, how I have my code set up, that it's confusing me.
You know, that's probably true. And syntax errors can dog you for a while, and then you get used to spotting them and what they mean. And you get used to the idea that just because the error appears on a certain line does not mean that's where the error is. It might be that there's some syntax error before that line that's causing a cascading effect. So it's a practice of backtracking. In fact, one of the things that developers often do is that when they have an error like that and they're not sure what's causing it, they'll start commenting out lines of code to see when the problem stops. And sometimes if you do that, the problem will stop and you'll know that the line you just removed was the line that was causing the problem. And then that can kind of help you figure out where your syntax error is or where your logic error is. depending on the nature of the error. Does that make sense?
Yeah, it does.
Someone is suggesting in the chat, they're saying, hey, Sophie, why don't you send a pic of the error? Since you're on your phone, you could send me a picture of the screen. I could take a look at it so that it's not projected in the stream. And then I can read your code. And you know what? It's one of those things where I've been doing this for so long. Sometimes I get really lucky and I can spot the error right away. So is there a way for you to send me sort of a snapshot of your code, or maybe you could send me the actual code file that I could open up in a text editor?
Yeah, I can zip it and send it to you.
Don't zip it. If it's just the code file itself, that's pretty much all I need. If you can just take that file, like the Java file, and then just send that to me, I can work with that.
Yeah, I can do that.
All right, cool. So Sophie's going to work on that. In the meantime, I'm going to go ahead. Let's see. I don't have anyone else waiting to ask a question, so we don't have to worry about people on hold, if you will. Let's see. Okay, so Sophie's working on that. Have others of you had trouble with problem 2? That's a common problem to wrestle with. Part of it is that it's not a simple single check necessarily, right? In fact, to be honest with you, I'm thinking through it right now, and I think there is a way to write that as a single check. In fact, I can conceive of it in my head. But it often makes more sense to us as humans if we break that up into a couple of different checks. What I mean by different checks, and what I mean by single check is, here in the code, this is a single check right here. And similarly, if I had some other condition, if I was like, and if the number is also even, which is possible in multiples of 13, and if the number is also even, then do something. Well, even though I've got a compound here, it's still technically a single check in terms of it's a single if statement. This whole thing will evaluate to true or false as a single true or a single false in the end. But as a human, I might not see it that way. I might take this condition and say, okay, well, now that I know that it's a multiple of 13, inside of this if statement, I'm going to check to see if it is also even. Because if it's a multiple of 13 and it's even, maybe there's something I want to do. Otherwise, if it's a multiple of 13 and it's odd, do something else. Otherwise, if it's not a multiple of 13, take some other action, right? So just to kind of give you some notes here for readability, here I would say multiple of 13 and even. And then I would say multiple of 13 and odd. And then down here, in this final else, I would say not a multiple of 13. Whatever that meant in the context of this application. So I could consider how this primary check would result in needing additional checks if it were true. But it may be that if it's not true, there are no further checks to make, but there is some action to take. This kind of structure we refer to as a nested if statement. In other words, it's an if inside of an if. And at this point, you can have the tired meme, yo dog, right? If inside of an if. All right, let's see. Let's go here. General. Oh, I'm sorry I didn't get a chance to say goodbye to Encrypthony, but it was good to have you here on the stream, buddy. Shout out to you. And let's see, I'm going to go back to Facecam. Shout out to you, Mr. Meredith. All right. Let's see. I'm still waiting on Sophie to send that image. If you sent it to my email, let me know, because I don't have my email open for security reasons. When I'm on the stream, I don't want to goof up and show sensitive information. So I closed my Outlook email for that. Okay, let's see. I'm checking the chat for anything else that might be of interest. Da, 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 da. Angel Cookie, I am so sorry that you're feeling like you can't come on with voice. She's saying that um, her roommates have some stuff going on, and so it might create too much background noise. I apologize. I would love to speak with you on the air sometime. I think that'd be really great for everybody. Let's see. I need help. Someone is saying, I need help with month and day coordination and how to set that up with the birthday calculator thing. You know, that's a good point. And I don't want to do the homework for you, but one of the interesting problems with the month-day issue is that given certain months, you have a certain number of days, right? So January has 31 days. February has 28, unless it's a leap year when it has 29. And yes, you should account for that in your app. March has 31 days. April has 30. May has 31. And there's this nifty little knuckle trick. I don't know if you've ever seen this before, but if you have your knuckles, right? It's like you have a hump. So it's a maximum number of days, 31. So that's January. February is a dip down below 30. I'm sorry, I said 21, didn't I? 31 days. February is a dip, so it's not 31. March is a rise, so it's 31. And then April, June, July, and then you get to August. And August has 31 days, but so does September, right? So it's August, then September, and then you wait, that doesn't work, does it? That doesn't work at all. I know I've seen this work before. Hang on a second. January, February, March, April, May, June. I'm sorry, it's July. July and August have 31 days. I skipped a total month there. So sorry. So July, then August. They both have 31 days. And then September has 30. And then October has 31. And then November, December, right? So with that little pseudo mnemonic device, not even a mnemonic device, but with that easy to remember device, you can figure out which days have, or which months have so many days. February gets a little weird because you have to know if it's a leap year or not. But that aside, if you know that you have 12 possibilities, some of which, let's see, 1, 2, 3, 4, 5, 6, 7, 7 of which have 31 days, and then you have 1, 2, 3, 4, which have 30 days, and then you have February, which is special. If you know that you have 7 with 31 days, 4 with 30, and 1 that's a special case, there's a way to write your logic so that you very easily find the maximum number of days in a month for validation purposes. I don't want to say much more than that. I will say this. You can use either an if, else if, and if you use it wisely with some compound operators, then you can reduce the number of if-else's you need. Alternatively, you can use a switch. And remember that if you have certain cases that all result in the same thing, you can line those up a certain way, and you can use a feature of the switch so that if one of them is true, it just cascades straight down to that same consequence. You don't have to list the consequence 7 times. You can group those 7 and have one consequence, right? So you might remember that as a demo from class. If you use a really well done if statement, or if you use a switch wisely, then you can very easily find the number of days in a month. Alternatively, and this is kind of a spoiler, but there is a library in Java that handles date and time. And one of the things you can do is you can put in a month and then find out how many days it has. I think there's a way to figure out leap year as well for February. That said, I'm going to warn you about this right now, and this is a Java thing. Java's built-in date time libraries suck, and everyone knows they suck. Major and experienced Java developers say they suck. In fact, in the enterprise world, the most commonly used date-time library in Java is a third-party library called Joda that does everything the way it should, is very easy to use, and with Java 8, they tried to reverse engineer that third-party library so that it would be built into Java, and they still didn't get it right. It's still not that great. They've actually taken a crack. Java has taken a crack at the date time libraries 3 times, and all 3 times they've been kind of garbage. But that said, in this particular circumstance, they can still be useful. They can still give you the information that you need rather simply. So you could write an if-else very well. You could write a switch very well, or you could look up how to use the date time libraries and use that to your advantage. Any one of those 3 solutions would help you, Angel Cookie, with your month and day issues that you're having. Okay? Alrighty. Let's see. We're at 10:35. I'm still waiting on Sophie to give me her code, but that's sort of like an individual code issue, and I don't think it's going to help people at large. And I'm happy to help Sophie with that issue, but I would much rather, go to like a more public, more universal issue if we could. So Sophie, I'm going to take you out of the live chat for just a second and put you over in the public channel. When you have a chance, just message me your code. I'll take a look at it. I'm trying to think if there's anything else more useful I could give you tonight. And it's okay if the answer is no. We have kind of a small stream attendance tonight, and that's okay. It was kind of last minute, and I'm okay with that. No big deal. But hopefully you got something useful out of this, and there are some pro tips in this stream that will help you with the current assignment. Past that, I'm trying to think if there's anything else I could show you. I showed you just a little preview of try-catch, which makes it so that we don't have to label everything throws IO exception. We can handle it ourselves. And if we handle it ourselves, the problem dies right there on the spot. I don't want a full-on demo exceptions just yet. I'm going to save that for actually being in class, unless you have a specific question about that topic. Let's see. Is there anyone else who has a question they would like to ask live during the stream? I'm going to check the general chat. I don't see anything new. I do see that we have a couple of new users on the Discord, which is great, because I want to make sure that you guys are involved. And let's see. Anything else? I don't see anything. So, Sophie, if you would send me your code, then I'll take a look at it. We can also look at it tomorrow morning before class during my office hours, or even a little bit after class when class is concluded. But past that, I don't see a need for us to keep the stream open any longer. I'm just double checking the Twitch chat to see if there's anything that I've missed. Let's see. Looking. Nah. The Twitch chat, this time the Twitch chat has remained useful. I'm very proud of you guys, just so you know that. And I don't see anything in the general.